This is a video to self, Jed, and the purpose of this is to have something for you to review and refresh your memory on how the OpenNet CF Padarn web server works. It's not going to be extremely thorough, but enough to hopefully give you the basic concepts of how it works and certain areas on the web to go get more help. Okay, so the background is OpenNet CF created a web server that you can run on Windows CE. The purpose of this is because Windows CE does not support managed code natively. So because we were developing a Windows CE application for the NextFlex controller, I created a demo app or a demo solution to just see how Padarn works on Windows CE, to see how it programs. And this is the name of the project or the solution that I made, NextFlex Controller Solution. And it implements Padarn, the Padarn web server. And so before we go further, let me show you on where to go to get some files, opennetcf.com. And once you get there, you can log in. And you log in with your username Jed, and your password is your standard password. And then if you go to the products Padarn, you can scroll all the way down and click the link down there, and you can see that on this page we got a Padarn developer's guide. This is, I recommend reading that just to refresh your memory on how it works. But these hands-on labs are very useful. It contains code and documentation, so I'm going to download this first one, HOLP100, and let's check it out. Inside of there is a PDF and an actual solution for Visual Studio 2008 or 2005. Keep in mind that you can't develop Windows CE applications in Visual Studio 2010. Excuse me. Anyway, let's look at this P100. This hands-on lab HOLP100 creating a web solution. This is a cool document to go through to creating your first Padarn solution. And I'm not going to go through it right now. Here's the deal. You already went through it, and you went through a few of them actually, and you came up with this solution here. It's your solution called NextFlex Controller Solution. And I'm going to zip this up and email it to yourself so you can search your Gmail and find this zip file later on and run it. But let me break down the solutions so far. I have 4 solution folders, as you can see, but at this point I'm going to only talk about this HMI project here, or solution folder, which contains 4 other solution folders. The server host is a project that came out of the HOL100 PDF file, and what it is nothing more than a Windows Forms project that is keep the color scheme. It's a Windows Forms, Windows CE Forms project that enables us to start, stop, and restart the Padarn web server. The Padarn web server, by the way, replaces the HTTPD web server that is natively installed on the Windows CE device. So you disable the HTTPD server, and then this Padarn web server will run in its place. And this allows us to run managed code, this web server. So that's all this is that. And it's broken up into its own project. Okay, now what's going on here? The next solution folder is, we call it static content. And in it contains nothing but static files that will be used and called by the browser client. So when somebody goes to Aquatrack, let's say something.com slash, in this case, live view slash default.aspx, they're calling this page, this default ASPX. And in it, we'll open it up, we'll see that this ASPX contains nothing but a page directive that calls or specifies that the code behind exists in a DLL with the code behind name. So code behind.dll is the name of the DLL that contains the code to run when this default default.aspx page is called. The inherits attribute specifies the type that will be ran when this page is called. And I'll get into a little more detail as we move on. But the point is, all of the Padarn ASPX pages will only contain an @page directive, which points to the DLL and the type that is supposed to be called when the browser client calls this page. In addition to that ASPX stuff, all of the CSS files and images and JS files will exist within this static content project. So the static content project is kind of straightforward in the sense that you store or you save all of your static content, your images and your CSS files, your JavaScript files, and your ASPX files within this project, and it really does not, there is no code that actually is ran within these pages, the static content. There's nothing dynamic about it, hence the name. Okay, the interesting stuff exists out here in the code behind project. The code behind project, notice that if we go to its properties, its name is, its assembly name is code behind, code behind, which is no coincidence why this ASPX, its ASPX page calls the code behind DLL. So, the assembly name of the code behind project will be the name that you reference in your ASPX pages in this code behind attribute here. But moving on, let's look at the code behind page, or the code behind default. So notice, okay, we have a default within the code behind DLL. We have a type named default. Its namespace is at code behind, so its signature would be code behind.default, which is, no, this is different. Let's go back to the code behind in the live view and this default page. So within the code behind project, we have a live view. We have a namespace at code behind.liveView, and then the type is called default. And so its namespace would be code behind.liveView.default, which corresponds with this live view default page in the static content over here. Here we are, live view, and then we have a live view directory within the inetpub directory, and let's open it up, and we have that page directive. It's code behind. It calls the code behind.dll assembly, and it inherits this type, the code behind.liveView.default, which is code behind.liveView.default. This class, which exists in the code behind project. Now, this makes it pretty clean in separation of concerns, because all of the static content is in its own project. It doesn't do any code, and all of the actual code is ran in the code behind project. But you could have everything in one project just by making sure that your ASPX page references the correct assembly and inherits the correct type. If you do that, then you're good to go. But separating it like OpenNetCF manual suggests makes the separation of concerns very clear and easy to follow. I mean, when you're looking at all of the Solution Explorer pages. I've already taken up 10 minutes. This is insane. I can't believe I talked this much. Okay, so let's jam here. All right, so I broke this down into making a master page in my code behind. And the master page, notice how I reference the OpenNet CF Web UI, the the Web HTML, and this master page is going to correspond to ASP.NET master pages, even though it's not ASP.NET master pages. I'm simulating the same idea. So this master page, that class that I made, inherits the OpenNetCF.web.UI.page page type. And within this OpenNetCF page class, you get a lot of goodies that make building the web page easy. So this is a good start, creating your master page that inherits the OpenNetCF page. And I create an OpenNetCF document, and this class is going to be one document. By the way, it's a OpenNetCF Web HTML document. And the way I structured this is in the page load event of this master page, I'm going to call other methods that live here. And so when the Padarn server runs this page, it only calls the page load event. And so just to break up the code, I build all of these other methods, and then I call them individually to create my flow, so I can easily debug or whatever. I can see how this page is loaded. And so you can see the first thing I do is check for a session, and the session is managed by Padarn. And then I build the header, the area that will be the horizontal menu on the top with the logo on the top left corner, that kind of structure. And then I call this, here's the interesting thing. Well, let me go look at add header. So let's go look at this code. And that's the add. The build header is what I wanted to do. Let's go to build header. So notice how we're building this header. I'm creating a string that has just a raw string here, building tables and some links. This is just a raw string, but it's raw HTML as well. And I'm using the syntax like this so that it makes things easier to write out. And by the way, we can, instead of doing double quotes, we can do single ticks here. So we don't have to. This is perfectly valid in the HTML spec. You can use single ticks. And the reason why I would want to do that is because in the double quotes here, if I just used one double quote, it wouldn't it'd be escaped properly, because remember, this is a string, and so I escape it with another quote. But that can be messy to look at, so if we just change everything to single ticks, it's just easier to deal with. That's the only reason. Okay, so I call this, the master page calls this build header method, then this string is built, returns it, and then it adds it to this master page's raw text. Well, no, I'm sorry. This raw text is part of the OpenNetCF structure, and I will add this string to this raw text, and this raw text I'm going to add to this master page's body, and this is done by the Padarn utilities here. So all I'm saying is, hey, add this raw text to the body of this master page. And then after that, I call the add head content. And notice how I have this as a virtual method, so any child classes can override this, such as the master page.head.title. Any child that inherits this master page can easily change the title, which we want, and the child can easily change the style sheet info if they wanted to. And we can add, a child can easily add scripts to the head as well. Now we go to the get body content. This is the most interesting of all the methods. This is a method that makes a call to the master page.body add. So this basically what we're saying is we want to add more HTML to the web page that is going to be delivered to the client. Well, this add method calls this build body content method, and this build body content method is abstract. So any child classes that want to inherit this specific master page must create this method, and it must return raw text, and the raw text that the child class will return is the content that will be displayed in the web page that is finally sent to the client. So for example, let's go to a let's go to this default liveview.default class, and notice how it inherits the master page. Of course, we have to use these OpenNetCF assemblies here, or class or namespaces, and so it inherits the master page class that I personally build, and it's forced to implement the build body content method. And in this build body content method, I am going to change the title of the page. I'm going to build a title of the page, and then I build my own content, this build content, and here it is. This stuff right here is all of the HTML that will be passed to the client. In this case, it's just a string. I return the string to this caller here, and then it returns the raw text. I'm running out of time here, so just to jam through, the point is that this master page, it creates the HTML for the header part and the footer part, but then allows children to build the body part, the body content. That's the deal with that. So download this application and run it and see to refresh your memory on how it works. But I think I covered the main gist of how it works to hopefully trigger your memory.